A Chevrolet convertible can brake to a stop from a speed of 60 miles per hour in a distance of 123 feet on a level roadway. What is its stopping distance on a roadway sloping downward at an angle of 10 degrees? We're going to start off by listing the givens. First, we know V initial is 60 miles per hour. We know that V final is 0 miles per hour since he comes to a full stop. We know that the distance to come to a full stop is 123 feet, which is x, and that the angle is 10 degrees. To continue with the givens, we know that gravity is 9.8 meters per second squared, and converting the velocity and gravity to feet, we're going to get 88 feet per second for velocity initial, and 32.1 feet per second squared for gravity. Now we draw a free body diagram of the car without the slope, and we get that the force of gravity is mg and is counteracted by the normal force, and we get the force of friction acting upon the car. Now we draw another free body diagram with the car on the 10-degree slope. We get that the force of gravity is equal to mg cosine 10 degrees, and the normal force to counteract that force. Then we get the force to the right at mg sine 10 degrees, and the force of friction to counteract that. We know now that the net force in the y direction is equal to 0. This means that the normal force minus the force of gravity is also equal to 0. We know that the force of static friction is equal to mu s mg. And we know that the net force in the x direction is equal to mass times acceleration in the x direction. And we know that there's the formula v final squared equals v initial squared plus 2 times acceleration in the x direction times delta x. And we know that v final is equal to 0, so this whole equation is equal to 0. And we want to solve for acceleration. After solving, we end up with a equals negative v initial squared over 2 delta x. Now we know that the force of static friction is equal to force in x direction. So we get that negative mu s mg is equal to negative mass times acceleration. Now we can plug in the acceleration that we got earlier. We get negative mu s mg is equal to negative m v initial squared over 2 delta x. Now, solving for mu s, we get mu s is equal to v initial squared over 2g delta x. Now we plug in the values into the equation we got for mu s. You get 88 feet per second squared over 2 times 32.1 feet per second squared times 123 feet. And you should end up with an answer of mu s equals 0.981. Now we need to find delta x. We know that on the slope, we know that the net force is equal of the y direction is equal to 0. Now we know that the normal force minus the force of gravity is also equal to 0, and that the force of static friction is equal to mu s mg cosine 10 degrees. Now we know that the force in the x direction is equal to mass times acceleration. So by combining equations, we get that negative mu s mg cosine 10 degrees plus mg sine 10 degrees is equal to negative m v initial squared over 2 delta x. Now, we need to solve for delta x in the previous equation. And we get delta x is equal to v initial squared over 2g mu s cosine 10 degrees minus sine 10 degrees. Plugging in the values for these, we get delta x is equal to 88 feet per second squared over 2 times 32.1 feet per second squared times 0.981 cosine 10 degrees minus sine 10 degrees. Solving for delta x, we come to find that delta x equals 152 feet.